Which are the pros and cons of adopting or choosing open source language model versus the commercial one? We have some pro, for sure, some concern about data protection and data governance. Then we can also have better result in some tasks because we can fine-tune the model with our data and in our task, and then we can create a competitive advantages in the market because our model is unique respect of the others. Some disadvantages, for instance, we need to have knowledge and time to find out which is the best language model that fit our needs, and then we need some skills and infrastructure to deploy our open source model for the inference time. I'm very happy to be here today in this amazing event. I'm Lorenzo. I'm a software engineer since 12 years now in the industry. I'm here today because I think that is very important to highlight the role of open sources language models in our field. For sure, today you see a lot of examples of use, integration, and application that you can build using a commercial or language model through API. But it is also very important to know what is the field, the environment where they are living, and the role of the open source language model. So I will try to make a very brief overview just to bring the context of where we are, and then I will give the talk, the speech to my colleague Nicolò, that we can go a little bit deeper with some example and some result in using them. Okay, let's start. First of all, from where we come from, let's say. This very large and useful language model didn't come from nowhere, but I picked these milestones in the evolution of the current state of artificial intelligence today. One of the most important date is 2012 with the paper of the deep learning and introduction of the convolutional neural network. Then we have the generative adversarial network in 2014. Then the paper attention is all you need with the introduction of the transformers architecture in 2017, then the first generative pre-trained transformer by OpenAI and by Google AI in 2018, and then GPT-3, the very high-performance language model in 2020, and then you know the time is going crazy until today with a lot of new models every week, a new application and new capability available to us. Here I will try to focus the evolutionary tree of a large language model. So it is a focus not just on every kind of deep learning model that are important to us, but just a focus on the large language model tree. So as you can see, there is a lot of language model today available during the history of the revolution. In this chart, this comes from a famous article available for in open source in GitHub. You can find it. You can see here some reference to find out it. So first of all, in this chart, we can see that some name of the models that are plotted here have a white background and other are colored background in their name. The colored background represent the open source models, first of all. So as you can see in this environment, we have a lot of very well-known closed source model like OpenAI and other, like that is presented here, but a lot of open source model. It is very important to consider them in this talk. we can also see this evolutionary timeline. It's the third one, it's not the last one, timeline that you can see here. I use this chart just to present one amazing thing that came out in recent years. So in this chart we have the time, and then we have the number of parameters of the model expressed in million. Over the time, this model is going bigger and bigger. Until the GPT-3 model, that for scale is the the dot in the upper right corner, as you can see, is another scale of dimension. This is one important aspect to consider because with this enormous larger scale in the parameter of the model, the performance of the model itself become really very impressive, as you can see today. And so the community is asking why and how this very large language model can have this kind of emerging capability that are so much better than the previous cited model and so on. It's a very interesting point, but just to consider the scale. Another timeline, sorry, maybe this is the last one, yeah, is that the fact that the model capability instead is going crazy just starting from GPT-3 in 2020, as you can see in this plot. But the awareness of the larger public started 1 year ago when ChatGPT is gone public. But the capability is pretty much the same as what it was in 2020, for sure, growing. But the fact that now we are all talking about this kind of capability is just because OpenAI released for the public for free the opportunity to interact and experiment with the power of this large language model. When I talk about capability here, sorry, because I try to say something quite crazy. This comes from an intuition by Andrei Karpathy, a very inspiring leader in the AI community. One of his last talk is presenting this idea that is very, very inspiring to me. So it is considering the capability of the large language model quite as the kernel of a new kind of operational system. In fact, right now, and maybe more and more in the future, they are able to interpret some kind of language, for instance, the natural language. English is the new programming language, as you can say sometimes. And then they have other capability that are going to increase all this aspect of an open source, an operating system. For instance, here you can, he is presenting the ability to be multimodal, so the ability to integrate with, to interact with text for sure, but also audio files and images or also video in input and in output, like a controller with some kind of external peripherals in parallelism with operating system. Then he can use external tools, classical computer tools like Python interpreter, terminal, calculator to perform specific tasks. He has some sort of file system as a secondary memory. Here the retrieval augmented generation, the pattern that you already know, is a way to augment to provide more information and more knowledge at almost runtime to the CPU to process the task, to complete its task. And then it says a certain sort of RAM, the local memory, which is the context window of our prompt with the LLM itself. Then it can go to the network using Ethernet, let's say, but browsing the internet to bring other knowledge, and can interact with other language model itself. So in this vision, a large language model could be considered as a sort of a CPU of of a new kind of operating system. It's very interesting, very inspiring perspective that we can see the state of this field today. And in this kind of virtual parallelism between a language model and operating system, we can also consider this kind of symmetry. No? In the operating system field, we have major, large commercial operating system, which is Microsoft Windows, Apple macOS, but we also have a very large number of different kind of open source operating system, basically based on Linux for sure, or Unix kernel, with a lot of different configuration or let's say specialization for what they are very good to do. In the same way, we have commercial large language model like OpenAI, Anthropic, Google, and so on, but also a large number of open source language models, mainly based on LLaMA model from Meta, which is one of the most important for the community today in the field of large language models. So a focus, very brief, on the LLaMA ecosystem, LLaMA model ecosystem. So the LLaMA is a LLaMA and LLaMA 2, LLaMA 2, sorry. Model is a model pre-trained by Meta and released in open source with all the weight of the network. And starting from there, the community going crazy, trying to use and fine-tune and customize and improve in very aspect, in very use case, this large language model to be more have better performance in specific use case, be more easy to compute, more scalable, more quantity, and so on. A lot of new kind of model can be based on LLaMA. It's very important to consider it because it's a big opportunity for us to consider some alternative to the closest source model. So this is my last slide. So just to introduce my colleague here, which are the pros and cons of adopting or choosing open source language model respect versus the commercial one. So for sure we have some advantages, which are, for instance, cost efficiencies. In many use cases, we can have better cost control using open source language model instead of paying for any call to the API. Maybe not maybe, but we have for sure some concern about data protection and data governance, the very different aspect of this using commercial and third-party model instead of using and hosting our open source model. Then we can also have better result in some tasks because we can fine-tune the model with our data and in our task. And then we can create a competitive advantages in the market because our model is unique respect of the others. So we have an advantage and we have some proprietary technology that we use to provide our services. So it's very interesting and there are very important aspects to consider when we are choosing the right model. For sure, using a commercial model is very convenient in some aspect because we can just consume them and then we can be very quick in test and trial and evaluate the result and in piloting some applications. But on the long term, I believe that the impact and the opportunity to consider open source model is very effective. Some disadvantages, for instance, I mentioned some of them. So we need to have knowledge and time to find out which is the best language model that fit our needs, because it's not so sure. But there are so many, you see in the chart before, so which is the right for me? We have to have experience, knowledge to test, evaluate, choose the right one. Yeah, it's not so difficult because once you have a bit of knowledge about that, but we have to consider the time. Then we need time to and the computational cost, if we want to evaluate and fine-tune and train, let's say in part we can train this model, and we have to consider the time that we need and the computational cost that are required. But this kind of time and computational cost are predictable and is fixed, so is more controllable than not just relying on something that can go very very high without our control. And then we need some skills and infrastructure to deploy our open source model for the inference time when we want to query the model itself. These aspects are not so critical because the community, the engineering and the machine learning field are working together to improve the tooling, to improve the easiness, let's say, to adopt this kind of model. In the time, it will become more and more affordable for everybody to directly use this kind of open source model. And so it is time for me to introduce Nicolò, my colleague, a very expert in the machine learning and natural language processing field, and is a researcher scientist, and it's an honor to me to have here today. Thank you, Nicolò. Thank you, everybody.
Okay, hi everyone. I'm Nicolò Tamagnone. I work as a NLP, machine learning NLP engineer in a data-friendly space that is a little international NGO. So I mainly work on or try to developing NLP models or machine learning models in general for the humanitarian sector. My presentation today is connected, a sort of continuation to the one of Lorenzo, and the title is Open LLM, No Reason to Fight. It's just a provocation a bit, but just is clear that in the community of the NLP and machine learning research, there is a sort of fight between the closed LLM, so the LLM developed by mainly OpenAI, and the open source alternatives. But today I want to try to show that probably there is no reason to do that, in the sense that it's the best choice, and probably this is the path that a lot of researchers, a lot of engineering in the sector are trying to do, is to run in an alternative but parallel way in respect to the general purpose and business open LLM. We are talking about NLP, so about natural language processing. The two big families of tasks, let's say downstream tasks, in this kind of machine learning branch are two, the generative one and the predictive one. Nowadays, with everybody of us used for sure for testing, but also for work purpose, ChatGPT or the GPT API or other, let's say, natural language application that use large language models, where all the tasks are generative, but not everything is generative in principle. We have predictive tasks, like very classic example, like text classification or entity recognition, like detecting like some entities in the text, or linking of these entities, or the semantic parsing, a very old-fashioned but important task in NLP in respect to the generative one. Nowadays, we only see problems like question answering, summarization, reasoning, chain of thoughts, and downstream tasks like this. Today, in fact, pretty much all these two families converged or merged in the generative sphere, in the sense that all the predictive kind of tasks, like the classification that we saw before, can be reshaped in some sense in a generative perspective. We can do that simply adding, like we use pretty much GPT every day, adding an extraction in an input and then asking for a kind of output too. And in this way, we can perform predictive tasks in a natural language shape, so in a generative shape. The two main, let's say, way to do that are or without any kind of training or fine-tuning that is called, let's say, in-context learning, so just asking and use the big capabilities of these new large language models and add some example in the prompt and receive some output. Or trying to do an instruction tuning, so translating, for example, a classification dataset in a instruction and output dataset and training a generative model, a large language model based on that. There are a lot of examples. One of the last one is the super natural instruction dataset that is a super big dataset that covers a lot of downstream tasks, predictive, generative, all mixed together in an instruction answer, so in a question answer shape. Here I just show some result in the first table of a very recent article titled PromptNer. PromptNer is just a name entity recognition task that we saw before is a predictive kind of task in a generative way, using and, let's say, trying to make a comparison between some other name entity recognition model with using GPT 3.5 and GPT-4. All very nice, impressive result, also considering that here we are not talking about any kind of training, any kind of fine-tuning, it's just a few-shot learning or zero-shot learning, just using out of the box a model and getting the output. Very nice, impressive results, but we can just for this talk make a comparison between this result and the actual state of the art in respect of the same evaluation dataset, the co-NLL, in the 2021, and we see that, however, we have a big difference. And we have a big difference also with a very old-fashioned, here it is really old-fashioned, of 2003 result. Here we are not talking about deep learning, we are talking about very basic NLP, and that perform anyway better than PromptNer GPT-4. Of course, just to underline the fact that the comparison is not really the same. In one case, we have result out of the box without any kind of fine-tuning. The other are fine-tuned models. So, and if we try to make some fine-tuning on ChatGPT or on some large language models, we can see in a very similar kind of task, always a name entity recognition task, is UniNer, 7 billion is just a fine-tuning of a LLaMA model. is a good example of a overperforming open source little model compared to the ChatGPT 1, so the GPT 3.5 instruction that with instruction tuning on a specific predictive task. We can see here just at the bottom of the slide, however, there is this comparison with a classic BERT-based fine-tuning, and we can see that anyway, a BERT-based model maintains is still competitive overall. There is a difference, but not too much. However, nowadays, in the world of LLM, no open source model are better quality, even that GPT 3.5, except for really some specific evaluation dataset. But in general, this is the chatbot arena leaderboard. That is a famous leaderboard for the evaluation of large language models, both closed proprietary models and open source model, in respect of some, a lot of evaluation benchmarks, like the MMLU, that is probably one of the biggest evaluation dataset in NLP, that cover 57 multitask downstream tasks that cover pretty much everything from classification, question answering, name entity recognition, and so on. And also, let's say, more focused conversational benchmark, like the empty bench, the multi-turn conversation. So evaluation of chat-based result. We can see that the best model is not even better than GPT 3.5. So some consideration at the middle of this presentation. We can see that for some specific predictive task, a classic fine-tuning is still competitive, but with order of magnitude smaller models. We are talking about, BERT. We are not talking about little model, but little for sure than GPT or also LLaMA model. For general purpose LLM, from the previous slide, we can see there is nowadays no comparison between closed and open LLM. There is a lot of work to do in this sense, if possible. And some consideration, taking these two pivots, that open source models are already, anyway, quite powerful. We have already some example, like the fine-tuning of code LLaMA, 35 billion parameters, that is a instruction tuning of LLaMA 2 on coding question answering, so instruction and output, that nowadays, today, maybe not tomorrow, is a good example of a state-of-the-art domain-specific model. And fine-tune models, so we can try to, let's say, answer to summarize all these considerations, saying that fine-tuned models don't need to reach the scale and generality of a model like GPT-4 or GPT 3.5. We can imagine that the open source world, the open source community, should focus on developing sustainable and smaller and domain-specific, more focused models. So there is no need of trying to replicate or compete with big LLM or private LLM, on trying with a lot of resources, training, pre-train LLM of the same size, but trying to use open source models, open source LLM, in a different scale, in a smaller order of magnitude, but try to having that where we can, in general, obtain better result. Here just a couple of examples of domain-specific model. Here biology. That is a very common task in NLP. Is a field of science where NLP is used a lot, where we can see that the open source fine-tuning of BERT model is not still competitive, is better than GPT 3.5 and GPT-4. And here, an example from my use case in the humanitarian sector, where a lot of predictive tasks are needed in the sense of analyzing document and classify document in respect of some humanitarian analytical frameworks that sometimes can be very complex with a lot of different labels, more than 80 labels. We can be in a multi-label classification scenario with also a structure between the labels. And here it's just a comparison of a BERT, so a fine-tuned BERT style language model in respect to the result that we can obtain with a few-shot classification using GPT-4. You can see in this case a big difference. Each bet is just only to underline the fact that for this experiment that I ran, each query that contain pretty much 10 different sentences cost $0.2 per query. And or that if you can imagine to scale that, I don't know, in 100,000 different sentences, it can cost a bit. Or changing order in some example changed the result, so a bit lack of stability. In general, good few-shot result, but impossible to use in a production environment. Here is just another example between embedding-based classification in respect to the OpenAI embeddings. So we see that with the open source choice, we can fine-tune anyway something good, more specific, smaller, and more easy to use also in a production environment. If I don't want to use a BERT model, I want to be in line with these new technologies and capabilities of big pre-trained LLM. So we can, however, do something. Not the pre-training, so we can't imagine now in the open source world to train from scratch a large language model. Here just, this is the official table of Meta about the computing hours of one GPU for training LLaMA. Is just just an example. They didn't use only one GPU for train LLaMA 2, but we can see, pretty much 200,000 hours. So it's a prohibitive cost. What we can do in using open source LLM is to approach that in a fine-tuned setting, both native, that, however, so classic kind of fine-tuning. So we build a data set, in this case an instruction-based instruction tuning data set. We fine-tune all the parameters of a pre-trained open source model like LLaMA 2 7 billion, for example. But however, it's something that needs some resources. Here just an example of how many GPUs you need for training the biggest LLaMA 2. And of course, it will last 1 month or two, 24 hours a day. What we can do, and is very now probably the most hyping and research field in the sector, is to find some solution for training and fine-tune this LLM with some, let's say, workaround that can be some that are called low-rank adaptation or quantized low-rank adaptation, so trying to find a way that can be memory friendly and also cost friendly. Using this technique, we can imagine to train a 65 billion parameter model on really a single GPU. And I'm not talking about high-level GPU, but consumers GPU. Here, just we don't need to go now in the details, but we can nowadays, thanks mainly to the Hugging Face community that is in the field of NLP, the biggest community of open source solution for this kind of task, we can pretty much train and fine-tune a LLaMA 7 billion with, I don't know, 20 rows of code, 20 lines of code, just loading a model, quantize the model, so trying to find a discrete version of a continuous number, float numbers, adding some matrix inside the architecture, freezing the original pre-trained model, and train these adapters on that. Very straightforward. It's something that everyone can run also directly on a Colab environment or in a local machine, and also serve, for example, in a server without need of big or super expensive GPUs. There are also a lot of post-training quantization methods for adding very fast and solution to the resulting models. Nowadays, there are also in the open source world a lot of easy to use UI that, let's say, merge, join together all the different fine-tuning of this on a open source LLM. The most famous one is GPT-4All that in the background implement all these, let's say, quantization or workaround and low-rank adaptation and so on, just directly in a user interface. Or there are a lot of open libraries, one of them is Axolot, that support different technique, the same that we saw before, that can, just command line tools for running this kind of fine-tuning. Just selecting a base model from a list, the LLaMA 2 or other open source model, building up a dataset and run a training. And that's it.